Bismillahirrahmanirrahim. Okay, I'm going to review here chapter 8 stuff, okay? Because this stuff is important. It's actually important for day-to-day stuff. The concepts that we use here are very commonly applied to real-life situations. So in the morning we reviewed quite a bit of it. So, but I'm going to do it again because everybody needs to know. And then we'll talk about that little trivia. So this chapter talks about exponential functions. Okay? First thing you have to know what the heck is the exponential function? Okay, that's the first thing you have to know. So if somebody asks you, stops in on the side of the street, hey, what is the exponential function? You tell them y equals mx plus b, right? Wrong, that's a linear function, right? So what is an exponential function? That's the first thing you have to know. See, exponential function, here's an example of it. Exponential function is when the variable, which is the independent variable, I'll put that in parentheses now, I'll explain to you what that means. When the variable is the exponent, when the variable is the exponent. See, this equation, this function right here, this has an exponent, but this is not an exponential function. Okay? This is not exponential. That's a quadratic function, which we'll talk about some other time. But this is the exponential function. When we say independent variable, we mean like the input. When the input is the exponent. See, x is the input and y is the output. The value of y depends on the x. So the x is the independent variable, y is the dependent variable. Do you understand? So, x, when the independent variable is the exponent, that's why it's called an exponential function. So this is an exponential function. And then we talked about previously about the parent functions. Parent functions of exponential functions, or parent exponential functions. There are two of them. There's not one, but there are two. And the first one is y equals 2 to the x. Okay. And the second one is y equals 1/2 to the x. So these are the parent functions. And then then you have to, okay, what is a parent function? What does it mean for something to be a parent function? A parent function is a representative function. It's the most simplest function of that category of functions. You understand? And if you understand the parent function, you understand a lot about the qualities of that type of functions. Do you follow? It's like the example I gave you guys this morning is, if you meet a zebra, if you understand what a zebra is, would you agree that you understand zebras in general? Yes or no? Zebras don't fly, right? That's one thing. I doubt that animal is going to fly. So when you know one zebra, you know a lot about zebras in general. They have stripes, black and white, right? They eat grass, they don't fly, they have hooves, etc. Same thing. Parent function is the most basic function of that category of function that allows you to understand the whole host of other functions in that category. Do you understand that? So it's very important to understand the parent function. Does that make sense? So you kind of have to memorize the characteristic features of these functions. In other words, what makes a zebra zebra? The stripes and all that kind of stuff. So what's unique about this function? It's not a line for one thing. Do you understand? So you have to understand, Usman, the uniqueness about these functions, the characteristics that are peculiar to this function. Does that make sense? So we talked about the first one. Let's talk about the first one then. So the graph of y equals 2 to the x, okay? Now first, what's the y-intercept for this thing? What's the y-intercept? Okay, now what's the y-intercept? Very good. It's 1, right? See, y-intercept, you have to understand the concept, right? If I give you any function, let's see if I give you a complicated function like this. So f of x equals x cubed minus x squared minus 4x over 3x minus 5. Okay? What's the y-intercept of this function? Yeah? But you have to understand the concept first. What does it mean for something to be a y-intercept? Okay? So let me draw some lines. Here's a line, okay? Here's a line. These are not exponential functions, but we're just using them as examples, okay? Now look at all the y-intercepts, okay? Here's a y-intercept, here's a y-intercept, here's a y-intercept, here's a y-intercept, and here's a... Oh, they all have something in common. Yeah, y-intercept is the value of the function when x is 0. So if you want to find the y-intercept of any function, you plug in blank for the value of x. You plug in 0 for the value of x. So the y-intercept is the value of the function when x is 0. Got it? So what's the y-intercept of this function? You plug in 0 for x. So y equals 2 to the 0, and that is 1. Yes. Anything to 0 power is 1. Okay? So this function has a y-intercept of 1 right here. Okay. And then as the x value goes bigger and bigger, the function gets bigger and bigger like this. So if it's 2 to the 10 versus 2 to the, let's say, 15, or 2 to the 50, y equals this, right? And then 2 to 1,000, the function goes bigger, 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 right? And then the x value goes smaller, the function goes like this. Do you understand? Like x, yeah? Watch this, x to the negative 50. That's going to be 1 over 2 to the 50. That's a very small number, right? So, the first thing that you have to understand is, what does this function look like? That's y equals 2 to the x. That's the parent function. See? You have to know the characteristic feature of this function. It's not a line, and it's the y-intercept is there. There's another feature about this function, is that this function never goes beyond the x-axis. So this area over here is haram for this function. It's prohibited. You can't get there. Y is never a negative number for this function. This function would never pass this line, okay? Why? There's no way you can make y a negative number. There's no way you can put anything for x and get a negative number. Do you understand? Let's say if you put a positive number, y equals 2 to the 1,000, that's a very big number. Y equals to the negative 1,000, that's like 1 over 2 to the 1,000. That's still a positive number. Do you understand? So this function will never have a y value that's negative. Correct? Okay. That's another thing. Now, when a function like this, okay, it approaches this x-axis, but it never passes it, right? It goes one of these. So you can say that this x-axis right here, okay, you can say the x-axis is an asymptote of that function, right? So asymptote is a line. It's a line that the function approaches, but it never reaches. Do you understand? So the x-axis is an asymptote of this function. Does that make sense? Okay. Got it. Now watch. Superimposing this, the other parent function. Well, 1/2. This is the other parent function, right? Now, what's the y-intercept of this? What's the y-intercept of this function? What's the y-intercept of any function? When you plug in the 0 for x, right? If you want to know y-intercept of it, you plug in 0 for x and see what the value of y. If you put 0 over here, you get what? 1. The y-intercept is still the same for this function. It's 1. But as x gets bigger and bigger and bigger, right? Let's say x is 1,000. Okay? This is like, you distribute the 1,000, right? So 1 to 1,000 is just still 1, and 2 to 1,000 is like this, right? It's a very small number. So the bigger the x gets, the smaller the value of y, like this. Do you understand? On the negative side, okay, let's say it's 1/2 to like negative 1,000, okay? Now, this negative means you flip it, right? The whole fraction is flipped, right? So this is like 2 over 1 to 1,000, right? Everybody understand? So that's like 2 to 1,000. It's a very big number. So on the negative side, the bigger the negative x, so to speak, it goes like that. Do you understand? So that's that function. So that's the other parent functions. If you draw this out, so it's y equals half, which is 0.5 to the exponent x. Look at this. See? That's the other parent function. Now look. So how are these two functions related? They are mirror images of each other, correct? So these two functions are mirror images of each other across the y-axis. They're mirror images about each other across the y-axis. Got it? Yes, yes? Yes. I'm proud of you. Got it. You can take a nap if you want. Alright. Watch. So y equals 2 to the x. Let's explore this function more, okay? So y equals 2 to the x is like this, right? So y-intercept is 1, and the function goes like this, okay? Now, how does this compare to this? Y equals 3 times 2 to the x. So what's the y-intercept of this function? Very, very good. It's 3, right? Because if you put 0 over here, this becomes 1. 3 times 1 is 3. So if this is 1, the y-intercept of this one is 3. Got it? Then what? Then it's going to look very similar to this, right? But it's going to go up faster, right? Would you rather be paid this, or would you rather be paid that? You'd rather be paid this, right? If you want to make more money, because it's going to go up faster. Your income is going to go up faster for the number of hours you work. Does that make sense? So this graph is going to go up faster. Like, it could be skinnier. It'll be hugging the y-axis more. Do you understand? It also is going to go down faster, like this. I didn't quite do that right. It's more like that. That's what I'm saying. Like this. You follow? Okay. Does that make sense? Okay. Let's see how it looks over here. Let's put 2 over there, and let's put 3 times that. Now look. You see this? So parent graph. Like this. Okay, I'm sorry. So it's like over here, and I'm going to go down over here. Okay? So that's y equals 3 times this. Does that make sense? Okay. And okay, what now? Before we do this, this should be. It won't go beyond this actually. Why would it not? Because it's always going to be bigger than this. So this is actually incorrect the way I did it initially. See? You will always be higher than the black one. Because the pay is always higher, so to speak, in the other function. Okay. Now, we did this. So we gave you the parent function, and I gave you this example. Okay, how about this one? Y equals -1 times 2 to the x. How's that look? What's the y-intercept? -1, right? It's a mirror image of this parent function, like this. Got it? Because every y value is just going to be brought down over here. That's the mirror image across that. Got it? Okay. And then we can see why we can write a general equation like this. Y equals b times a to the x, right? Where this is the y-intercept, and that's the multiplier. Got it? Y-intercept, that's the multiplier. I explain to you what this is, because you need to know this to answer the question that we're talking about. Okay? Okay. Now, y-intercept and the multiplier. Fahmed? Watch. So if I give you this, y equals -4 times 2 to the x, what's the y-intercept? -4, right? And this function Negative 4 is the y-intercept, and it's negative. It's going to be mirror image of the parent function. It's going to kind of look like this, right? Okay. One last one, the same example. What's this one? So this is y equals to the parent function. How does this look like compared to the parent function? So let me draw the parent function for you. The blue one is going to be y-intercept is 1, and the parent function is this. So how does this one look like compared to, huh? Yeah, it's going to, see what's going to be, what's the y-intercept of this one, the new function I gave you? 1. Huh? 1. We plug in 0 for x, right? What do you get when you 0 for x? 4. The y-intercept is 4. That's the y-intercept. It says 1, 2, 3. That's the y-intercept. So that's going to be the y-intercept. And then what? So it's going to be like this, right? Correct? Wrong. No, it's not going to be like this. Because this function is the same parent function. The whole function moved up by 3 units, okay? Now, do you understand? It's the whole parent function. The whole function moves. It's like moving the whole desk up. Everything is up. Which means, if the parent function has an asymptote that's this, you move the asymptote 3. You just take the bloody asymptote, move it up 3 units over here like this, so to speak. You know what I'm saying? Nobody's here. Safe. Do you understand? So you move the asymptote. This function will not go past beyond that. Okay, it will not go past this. There's a big difference between this one. Now look at this one and compare that to y equals, okay, 3 times 2 to the x. Now this function will have a y-intercept, okay, if I look, watch, 4 times 2 to the x. This function will have a y-intercept of 4, same place, but then it will be like this. Do you see the difference? Do you see the difference? Okay? So let me just make sure you understand. Y equals 2 to the x, then it's y equals 2 to the x plus 3. This is the whole function moved up 3. Y equals 4 times 2 to the x. This is, the y-intercept is 4, but it will still, the asymptote is still going to be the same as the parent function. Does that make sense? Okay? Now, just watch this, okay? So that's this function. Now, we can look at this one. Y equals 4 times 2 to the x plus 3. Watch. See? So this green function is the parent function moved up by 3 units. This one just moved the whole thing up by 3 units. Does that make sense? Including the asymptote. Does that make sense? Okay? Alright, so now you understand. So this is the general formula for exponential function. This is the y-intercept, and that's the multiplier. Okay, what about the multiplier? What does that even mean? Okay? What does that mean? Okay, now I'm going to explain that to you. What is this multiplier business? So I'm going to put 2 functions over here, okay? Okay? This is going to be a linear function. Y is going to equal to 2x plus 1. You agree it's a linear function? I hope so. Y equals, okay, 3 to the x, okay? Are you okay with that? So let's pick some values over here for ourselves, all right? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Mucho importante, señor. So why listen to me, all right? Okay? When x is 0, what's y over here? Over here. 1. When x is 1, what's y? 3. When x is 2?
5, 7, 9.
Got it? Okay, how about here? When x is 0, y is? X is 1, x is 2, x is 3, X is 4. Correct? Did I do it right? Yes? Alright, now watch. Do you see this? Watch this. Okay. Extremely important. This is a linear function. How's that linear? This is an exponential function. You agree? This is the heart of the concept. The key. From here to here, look, it's going from 1, 2, 3, 4, every unit. From here to here, you added 2. Correct? In other words, the rate of change was what? 2. You're adding 2 every single time. Do you understand? The rate of change was 2. What do we call the rate of change? The slope. Look. You understand? The rate of change is constant. The same. 2. Okay, now watch this. From here to here, I multiply by 3. 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 Now, from one to another one, okay, it's being multiplied by a constant. So what's the multiplier? The multiplier is 3. That's why it's called a multiplier. Do you understand that? That's why it's called the multiplier. So you can figure out what that A is if you can find the multiplier. See, for a linear function, you're adding the same thing. The rate of change is the same. But for exponential function, it's the multiplier that's the same. You're multiplying by the same thing. Do you understand? That's the difference between exponential function and a linear function. And that is the reason why y equals b times a to the x is called, this thing is called the multiplier. So from here to here to here to here is a times a times a times, you understand? It's like that. Does that make sense? Okay. Then it becomes very easy. Okay, if I give you this function over here, right? It's going to take me a little bit of brain work, secret brain work to figure this one out, okay? Alright, so okay, now watch. First thing you have to figure out is this. I hope I did the mental math right here. Okay, I'm not guaranteeing that, but look at this. First thing is you have to figure: is it a linear function or exponential function? I'm telling you, it's one of those two. Okay. If it's a linear function, then the rate of change is being added, right? It has to be the same. From here to here, you added what? Plus 4, right? Is this plus 4? No. So it ain't no linear function. Not from this planet anyways. Do you understand? Then, okay, then we say, okay, it's going to be an exponential function. What's the multiplier? Huh? It's 3, right? From here to here is 3, right? So now you can write the equation of this function. So what's the equation? It's going to look like y equals b times a to the x, right? So what's the equation of this function? Y equals? What's the y-intercept?
1.
No. The y-intercept is the value of the function when x is what? What's the value of this function when x is 0? 2. Because I gave it to you. It's right here. See? I recorded this. Put it on myself. Okay? So, the y-intercept is 2. So you put 2 over there. What's the multiplier? 3 to the x. That is equation of this function. It's that easy if you understand the concept, the y-intercept. So you have to know what y-intercept is. as a concept. Do you understand? It's the value of the function when x is 0. Right? So, now, doing okay. One thing, I'm going to pause after that. I'm going to do one more thing, and then we're going to pause for like 2 minutes, and then we'll restart. So we talked about this parent function considerably. We didn't talk about this parent function, but I told you this parent function is a mirror image of the other one. The y-intercept is what? 1. The invisible 1 is a 1 there. Y-intercept is 1. This function looks like this, right? You agree? You have to know how these parent functions look like. Okay, this one looks like this. Okay? This one looks like that. Do you understand? Okay? So, how about this one? Y equals negative 1 times 1/2 x. How does this one look like? It's going to be a mirror image of the other parent function, right? So if this was like the original parent function right here, if this was y equals 1/2 to the x, like this one is going to have it's going to be a mirror image like this. Does that make sense? Yes? Okay. Yes? How about this one? Y equals 1/2 to the x plus 3. How is that going to look like? Everything is going to be moving, including the asymptote. Correct? The whole function is never going to touch the it's never going to even touch the y equals 1 line even. The whole thing's going to be moved up 3. Right? Okay. How about this one? If I put a negative 1 over here, it's going to be the mirror image function moved up by 3. So you draw this one, which is negative 1. Okay? Right? Correct? That's this part of it. And then you move up the asymptote 3. 1, 2, 3 over here. That's the new asymptote. So everything's going to move up 3. It's going to look like that.
So will it turn into positive?
No, it won't. It will be like this. Like this. Watch. It's going to be negative 1 times the quantity 0.5 to the exponent of x plus 3. See? The asymptote is moved up too. What's the new asymptote? Okay, for 100 points, what's the new asymptote? What's the equation of that asymptote? Y equals 3. See? I'll move this point, see? See right there? Do you understand that? Okay? Now I'm going to summarize these two parent functions, okay? So the first parent function is y equals 2 dx, and the second parent function is y equals 1/2 to dx, okay? And they can both be summarized as this: y equals b times a to the x, where b is the y-intercept, a is the multiplier. If a is greater than 1, the function will look like this. Okay? If a is less than 1 but greater than 0, between 0 and 1, like half, the function will look like that. Do you understand that? Does that make sense? So you have to figure, if the multiplier is less than 1, it's a decay function. It will go down. If the multiplier is bigger than 1, it will look like exponential growth function, like the first one. So these are the two parent functions, and you have to understand them down cold. Like, like Arctic cold. You know Arctic cold? Arctic cold on the coldest day on Arctic, when the planet is farthest away from the sun. Understand? Alright, so you have to really, really, really know this, okay?